It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. In our digital world, data isn't just important, it's literally the engine behind almost everything we do. From the huge companies that shape our economy, all the way down to the local services we use every day, it all comes down to one thing: how well you can manage data. And right at the heart of that is the database. So let's pull back the curtain and really see how this stuff works. You might not even realize it, but you're a database user. You probably use them dozens, maybe even hundreds of times a day. Think about it. Every single Google search, every time you scroll through Instagram, every message you fire off, each one of those actions is basically a conversation with some of the most powerful and complex databases ever built. So what is the tech that makes all this possible? What's that engine running under the hood that stores all those photos and posts and messages and somehow lets you pull them up in an instant? Well, that's the big question we're going to answer right here. Alright, so here's our game plan for today. We're going to make 5 key stops. First, we'll start with the absolute basics. What is data? Then we'll clear up that classic mix-up between a database and a DBMS. After that, we'll check out the 2 major paths data organization has taken. We'll dive deep into the super-structured world of relational databases, and then we'll finish up with the flexible toolkit of their non-relational cousins. Okay, let's kick things off at square one. Before we can even talk about organizing data, we need to be on the same page about what it even is. And the simplest answer is actually the most powerful. Data is just a record of a fact. It's the raw material, the building blocks of our entire digital universe. So what exactly is data? Just think of it as any single piece of information. It could be your name, your age, your birthday, but it's also your address, right? Or your bank balance, or the model of your car. Every single one of those is a storable data point. And data isn't just text and numbers, not at all. It can be an image, a video file, a whole document, or just some plain old text. For school, for instance, data could be all the details about its teachers, its students, the subjects they teach. You get the idea. As you can see, data is literally everywhere, and it comes in every format you can imagine. So now that we know what it is, where the heck do we put it all? Okay, this brings us to a really important point, one that honestly trips up even people who are pretty tech savvy. You'll hear folks use the terms database and DBMS like they're the exact same thing, but they're not. They're fundamentally different. So let's clear this up once and for all. First up, what is a database? The absolute best way to think about it is just as a container. It's an organized collection of data, kind of like a digital filing cabinet, all stored electronically in a computer system. And the whole point of putting data into this container is so we can easily get to it, change it, protect it from anyone who shouldn't see it, and of course, analyze it to find some cool insights. So if the database is the container, then what's the DBMS? Well, the DBMS, or Database Management System, that's the software that acts as the manager of that container. It's the gatekeeper, the librarian. You see, you don't interact with the raw data container directly. Nope. Instead, you use the DBMS to create your databases, to manage them, and to store, modify, or grab the data inside. And this right here shows you the whole picture. You, the user, you're interacting with an app. That app then talks to the DBMS, which is the only thing that can actually touch the database itself. It's that essential middleman. And this is where you hear those big names, right? Like MySQL, PostgreSQL, or MongoDB. They are all examples of this powerful DBMS software. Okay, so we've got all this data, and we've got these systems to manage it. But how do we actually organize it inside the container? Over time, as the amount of data and its complexity just exploded, our methods for organizing it had to evolve right along with it. The whole story of the database really starts way back in the 1960s. The first types were super simple flat file databases, where data was basically just stored in files like a CSV. A bit later, we got hierarchical and network databases, which tried to create these parent-child relationships. But honestly, they kind of struggled with really complex data connections. And that struggle led to the world we live in today, which is totally dominated by 2 major types: relational and non-relational databases. As you can see, relational databases are still the undisputed heavyweight champion, powering almost 3/4 of the market. They are the established solid bedrock. But that smaller slice, the one for non-relational databases, that's the big story of the last decade. Its growth just took off, fueled by all that massive, unpredictable data coming from social media and the dawn of big data. Today, you'll find that most major tech companies don't just pick one or the other, they actually use both strategically. Alright, let's dive into that bigger slice of the pie first. What exactly is a relational database? The one key word you have to remember here is structure. It's all about organizing data in a very predictable, very orderly way. So, in a relational database, all of the data is stored in tables. Yeah, just think of a simple spreadsheet. Each table is made up of columns, which define the type of data, and rows, which are the individual records. And every column has a specific name and a data type, like text or number or date, which basically acts as a rule for what kind of information you can put in there. But here's the thing. The real power isn't just in the tables themselves, it's in the connections between them. That's the whole relational part. Take a look at this Office database example. We've got separate tables for employees, managers, and departments. But notice how the employee table has a manager underscore ID? That little piece of data links directly to a specific manager in the manager table. And that manager in turn has a department ID that links over to the department table. It's this web of connections that lets us ask really complex questions. And the language we use to ask those questions? That's SQL, or Structured Query Language. Okay, now let's flip the coin over and look at the other side. If relational databases are all about that strict, predictable structure, then non-relational databases are all about one thing: flexibility. They were basically born out of necessity to handle the messy, massive, and totally unpredictable data of the modern internet. You see, unlike that one-size-fits-all table model, non-relational is much more like a toolkit with a bunch of different tools for different jobs. Each type stores data in its own unique way to solve very specific problems. So, we're going to take a quick tour of 3 of the most popular types: key value, document, and graph database. First up, we have the key value database. This is the simplest of all the non-relational types, for sure. Just like the name says, every piece of data is stored with a unique key. To store something, you just give it a key and the data, which could be anything, really. Text, a setting, a whole user profile, and to get it back, you just provide the key. It's ridiculously fast and absolutely perfect for things like user session information or caching data. Next up, we've got document databases. A good way to think of these is like a collection of digital file folders. Each folder, which they call a document, has a unique ID and it holds data organized in a format like JSON, which is just a fancy way of nesting information. But here's the magic trick. Unlike a rigid table, every single document can have its own unique structure. So in a product catalog, one item might have color and size, while another one has voltage and warranty. That kind of flexibility is perfect for content management or user profiles, where the information can vary like crazy. Alright, now for a totally different way of thinking. Graph databases. These databases aren't really focused on the data itself, but on the connections between the data. Information is stored as nodes, which can be people, places, things, whatever. And the relationships between them are called edges. That popular graph database, Neo4j, which you see here, is a master at this. This model is just unbeatable for things like mapping social networks, building recommendation engines, or spotting complex fraud patterns just by following the connections. So to wrap this all up, when we compare the 2 main paths, it really just comes down to choosing the right tool for the right job. Relational databases, they enforce a rigid, predefined structure. That makes them awesome for structured data and making sure transactions are rock solid, like in banking. Non-relational databases, on the other hand, offer a flexible, dynamic schema, which makes them the ideal choice for the huge amounts of unstructured and semi-structured data that really define the world of big data. So we've gone on quite a journey, from simple files all the way to these complex, interconnected graphs. But the one thing that never changes is that the amount and variety of data just keeps growing, exponentially. And that leaves us with a really fascinating question to chew on. As our digital world keeps evolving, what new challenges are going to pop up, and what kind of databases will we need to invent to meet them? And that's a wrap on our deep dive into the world of databases. This explainer was based on material provided by Athir Mahir. Thanks so much for joining us.